Taiwan is an island of short, swift rivers. It suffers from typhoons, which bring heavy rainfall, as well as frequent earthquakes. Water laden with sand and mud inevitably flows into the island's reservoirs, making silting a common problem. Shihmen Reservoir is an important reservoir in northern Taiwan. It was completed in 1964 and has now been in operation for more than half a century. Shihmen Reservoir's greatest challenges are the swift rivers that flow through weak. It has experienced a number of extreme typhoon events that have resulted in heavy silting. Average inflow of sand and silt reached 3.53 million cubic meters, exceeding initial estimates by more than fourfold, resulting in silting of up to 33% of the reservoir's operational capacity. The effective lifespan of the reservoir was imperiled. If the silt flowing into the reservoir could be dredged, then the reservoir would have a sustainable future. To overcome this, the hydraulic engineering team pushed itself to the limit to formulate a desilting plan that could save the reservoir. Apart from the effective conservation management of the catchment area, Shihmen Reservoir makes use of a variety of desilting programs, including dredging at the Yixin Dam and the Liufu section of the midstream catchment area, and pumping out mud in the main reservoir area. Hydraulic desilting is the most economical method of preventing the buildup of silt. Shihmen Reservoir is the main water source for northern Taiwan. Under intense pressure not to interrupt operations, Shihmen Reservoir became the first reservoir in Taiwan to undergo desilting and installation of preventative measures to reduce future silting while continuing operations. The Shihmen Reservoir Power Plant desilting project was divided into two phases. Phase 1 was to bypass the power plant penstock number 2 by modifying it into a silt outlet. This would greatly enhance the effectiveness of desilting, reducing the rate of buildup and extending the reservoir's service life. Phase 2 was to create a branch line on the Shihmen Reservoir Power Plant penstock number 1 to maintain the function of the plant. The size and design of the valve had to withstand a hydrodynamic pressure of 14 kilograms per centimeter, requiring engineering of the highest international standards. Work on Phase 1 began in December 2009 and was completed within 3 years. After completion, the outflow of silt from the power plant rose from 68.6 cubic meters per second to 300 cubic meters per second, removing an estimated 1 million cubic meters of silt every year. This was the first plant in Taiwan to repurpose its hydroelectric function as an economic way of desilting, and it won a medal for outstanding public works from the Public Construction Commission of the Executive Yuan. In 2013, Taiwan was hit by typhoons Soluk and Trami. The sluice gates were deployed in reference to the most advanced time-domain reflectometry data, which indicates when density current flow has reached the dam and sedimentation has slowed. This is the optimal time for desilting. The results for Phase 1 were excellent, allowing an average annual discharge of 1.01 million cubic meters of silt and savings of 9,274 tons of carbon emissions. To ensure the reservoir's sustainable operation and improve its desilting functionality, there are now plans for digging a middle elevation discharge tunnel in the reservoir's catchment area. With the inclusion of the Amuping and Dawanping sluicing tunnels, it is estimated that an annual discharge of 1.35 million cubic meters of silt could be achieved. The purpose of the sluicing tunnel is to divert the lower stream of water with its high density of sediment in the upstream and midstream sections of the catchment area, bypassing the reservoir. This would divert the sediment directly to the lower reaches of the stream, thereby reducing silting in the reservoir. The Amuping sluicing tunnel has drainage, flushing, transport, and silt pumping functions. It is approximately 4 kilometers long. It can flush out 600 cubic meters per second, increasing the annual capacity by 640,000 cubic meters. The desilting operates when the water levels are low, and the tunnel is used to flush out or pump out the silt. During the flood season, flood discharge is used to flush out silt so that the sand and mud return to the original river flow. With the Dawanping sluicing tunnel, The method is to use density flow during the flood season for drainage and desilting. When the flood waters come, the monitoring station will note when the density flow has reached the silt prevention tunnel. It will then open the sluice gate so that the low-level, high-density flow will be flushed out, reducing the amount of silting inside the reservoir. The design team used great ingenuity and effective cooperation in drawing up a plan that took into account all factors and was fearless in the face of engineering challenges to Shihmen Reservoir, allowing this 50-year-old reservoir to gain a new lease on life.